In this video, we're going to be talking about dividing polynomial functions in function notation. So it says, let f of x equal 64x cubed minus 27 and g of x equals 4x minus 3. If capital F of x equals f divided by g of x, find a simplified expression for capital F of x. And list all restrictions on the domain. Alright, so let's write this function capital F. It's f divided by g. So function f, which is 64x cubed minus 27, is being divided by 4x minus 3. So that's the function before it's been simplified. Now let's talk about the restrictions on the domain. Remember, when a function is a rational function, meaning there's variables here in the denominator or two polynomials being divided, the restrictions are the denominator cannot be 0, right? So 4x minus 3 cannot equal 0. So we solve this to figure out what x cannot be. We add 3 to both sides, divide by 4. So x cannot be 3/4. That's the restriction on our domain. I can input anything else I want into x. I cannot input 3/4. Now, let's simplify this. Remember, a fraction bar itself is division. So I need to take the polynomial in the numerator and divide it by the polynomial in the denominator. I'm going to set up long division. And remember, we want our long division to be in descending order. So I'm dividing by 4x minus 3, and 64x cubed minus 27 is what's being divided. But I want to make sure I account for all the different degrees, right? So I have x cubed here, but I have 0 x squareds, and I have 0 x's, and then I have minus 27 as my constant. I need to divide, and I need to fill in all my placeholders for the different degrees. This is degree 3, degree 2, degree 1, degree 0, my constant. You have to fill these in, okay? Now I can start my division. So first I divide 64 cubed by 4x. I'm going to make a little side note here. 64x cubed being divided by 4x. I take the first term here divided by the first term there. 64 divided by 4 is 16, and x cubed divided by x is x squared. So that's what I write above, up top. 4x fits into 64x cubed, 16x squared times. Once we divide, so steps are always divide, multiply, subtract. Bring it down the next term, go back to divide. Divide, multiply, subtract, bring it down, bring it back. So I've divided. Now I need to multiply. 16x squared times 4x is 64x cubed. And 16x squared times negative 3 is negative 48x squared. Do you see why we needed this placeholder? Because I'm going to multiply and get an x squared here. So I need somewhere to put that x squared with a like term. So I've divided, I've multiplied. Now I subtract everything. 64x cubed minus 64x cubed is 0. 0x squared minus a negative. When we subtract a negative, it becomes plus. So 0 plus 48x squared is positive 48x squared. Bring down the next term. Bring it back to divide. So I'm dividing again. The leading term by the leading term. 48x squared divided by 4x. So 48 divided by 4 is positive 12. Whoops. Didn't mean to zoom that in so much. It's positive 12. Whoops, up here. And x squared divided by x is x. Now I multiply. 12x times 4x squared is 48x squared. 12x times a negative 3 is negative 36x. Now we subtract. 48x squared minus 48x squared is 0. That needs to always be 0. And then 0x minus a negative 36, subtracting a negative again, becomes positive 36x. 0 plus 36. Now we bring down our next term and bring it back to divide. So we divided, multiplied, subtract. We brought down the next term, go back to divide. So divide the leading term by the leading term. 36x divided by 4x. The x's divide out. I just have 36 divided by 4 is positive 9. Now we multiply. 9 times 4x is 36x. 9 times a negative 3 is negative 27. Subtract. 36 minus 36 is 0. Negative 27 minus a negative. Again, minus a negative makes plus. So negative 27 plus 27 is also 0. And there's no remainder here. So we end up with the function f of x equals 16x squared plus 12x plus 9, where x cannot be 3/4. So that is the function simplified with the restrictions on its domain.